Right now, you could be holding a share of a company, a deed to a house, or an ounce of gold encoded inside a single Satoshi. No one watching the Bitcoin blockchain will ever know it exists. Bitcoin only validates Bitcoin. So how can it carry assets it can't even see? Colored coins solve this puzzle. Colored coins are technologies that record the creation, ownership, and the transfer of extrinsic assets using Bitcoin transactions. An intrinsic asset is Bitcoin itself. The value lives natively on the chain. An extrinsic asset lives outside the chain. Bitcoin only points to it. Extrinsic assets split into two groups. Digital ones include stocks, licenses, game items, and intellectual property. Tangible ones include gold, oil, land, vehicles, and aircraft. The blockchain never holds these things, it anchors a claim to them. Coloring turns a tiny amount of Bitcoin into a marker for one of these outside assets. Picture a $1 note. Stamp it with the words, redeemable for 1 ounce of silver. Now trade that note as a silver certificate. Whoever holds the stamped note holds the claim to the silver. The $1 of value is incidental. The stamp is the asset. You could stamp it instead with ACME stock certificate and trade it as a share. The paper is just a carrier. Coloring works the same way. A Satoshi carries a separate meaning layered on top. Its Bitcoin value barely matters. The marker is what people actually exchange. The first true colored coin came from a system called EPOBC. It assigned an asset to a single one-satoshi output. The asset became literally an attribute, a color of that one satoshi. Spend the satoshi and the color moves with it. Modern systems go further. They store the asset data externally and rely on 3 interlocking mechanisms. Single-use seals, which spend a UTXO once, pay-to-contract, which hides terms inside a tweaked public key, and client-side validation, where only the recipient checks the history. Naming them is easy. Let's see what each does. Start with a shipping problem. A package carries a tamper evidence seal. As long as the seal is intact, the contents are untouched. Break it, and that break is permanent and visible. The seal can only be opened once. A UTXO is an unspent transaction output, a chunk of Bitcoin waiting to be spent. It has the same property. It can only be spent once. That single irreversible event is the digital equivalent of breaking the seal. In colored coins, you receive the asset to a UTXO. That UTXO is your sealed package. When you spend it, the spending transaction must describe the transfer. Spending equals association, and it can only happen once, so the seal tells you exactly when the coins move. But it doesn't tell you how. For that, we need a contract. The contract is where pay-to-contract comes in. Bob and Alice agree on the terms of a transfer. Alice has an ordinary public key, her underlying key. The system tweaks that key, mathematically combining it with a commitment to the contract. The result is a new tweaked public key. Here's the crucial part. To anyone watching the blockchain, that tweaked key looks completely ordinary. Full nodes see only a normal key. They never learn a contract exists. Its very existence is hidden. Because nodes never validate the contract, it can be arbitrarily long, written in any language, holding any terms you want. The chain doesn't care. It commits to the contract without ever reading it. The seal said when, the contract says how, and the chain stays blind to both. This hidden contract enables a powerful privacy trick. Bob holds a colored UTXO. His contract can split those coins. Half the color goes to Alice's UTXO. The other half goes to a completely unrelated UTXO, one with no visible link to Alice or Bob at all. To a surveillance system watching the blockchain, those two outputs look like two strangers receiving plain Bitcoin. There's no thread tying them together. The contract that defines the split is invisible. This also breaks a common assumption. The next owner isn't necessarily whoever received the UTXO Bob spent. The contract defines control and it can point anywhere. If nodes can't check the contract, someone has to. That someone is the recipient. This is client-side validation. When Alice transfers the asset to Dan, she hands him a private package of proof. It contains her underlying public key, the contract terms, the seal UTXO she received the asset on, and the full prior history of transfers, all the way back. Dan's own software then validates that chain locally. It checks each tweak, each seal, each spend, confirming the asset legitimately reached Alice and now reaches him. Dan never broadcasts this to the network. He never even sees the other half of Bob's coins, the unrelated UTXO from the privacy split. It's irrelevant to his ownership, so it stays hidden from him too. Validation isn't the network's job. It's a peer-to-peer conversation between the people who actually hold the asset. Step back and notice what we've built. A colored history that behaves like a private parallel blockchain, hiding inside the public one. Each transfer is anchored to Bitcoin securities through a real spend, so it inherits Bitcoin's permanence and ordering, yet the assets, the contracts, and the ownership chain remain invisible to everyone except the parties involved. This flips the usual model. Normally, everyone validates everything. The whole network checks every transaction. Here, only relevant parties validate relevant data. That's a profound shift. It means privacy by default, since outsiders see only ordinary-looking spends, and it means scalability, since the global network never carries the asset data at all. Three mechanisms make it work together. Single-use seals fix when coins move, pay-to-contract hides how, and client-side validation puts verification in the hands of the recipient, not the crowd. Clear up three traps before we finish. First, the asset is not stored on the blockchain. Only a tiny Satoshi marker and an ordinary-looking public key sit on-chain. The asset and its contract live off-chain. Second, Bitcoin nodes do not verify colored coins. They can't, and they don't even know a contract exists. Verification is the recipient's job. Third, receiving the UTXO doesn't automatically make you the owner. The contract defines control, and it can point to entirely unrelated outputs. These pay-to-contract foundations even helped shape the Taproot upgrade, which uses similar key tweaking. The result? Bitcoin becomes a notary for assets it never has to understand, securing ownership of stocks, gold, and the property it cannot see.